Hello, this is a hopefully quick update to the last video, and this method is much more comprehensive. So let's get started because there's a bit to do. So open up an Espresso window and we've got to drag a node out of the past. I think I've already done it. Yeah, I've already got mine here, so I'll get rid of it. Now, in System Presets Thinking Particles, drag this Python node out and drag it kicking and screaming into R23 and beyond by looking for line 25 and deleting the X in X range. And you should see it change. There you go. It's happy now. And I've also got to draw your attention to this line here, because this is the name to look for, UID underscore Maxon, which is a custom data channel. So that is that bit, and if you haven't got a user presets, click on this edit here and create a pool and call it whatever you like, and then drop that in and it's there for use. So I don't want that this instant. I've got a couple of example files, including the thumbnail file, but basically I'm going to try and build, well, let's just crack on and build something, because this is what I'm going to do for the next tutorial, which is simulation based. So starting with a sphere, which I'm going to make 250, and I did a quick rehearsal of this and I actually discovered something a bit odd. So with a matrix object in object mode with that sphere, which I'll just rename to spawn because it's basically our spawn object. And yeah, and the thing I noticed, which is odd, the count you set here, when you iterate through the matrices and spawn particles at their supposed locations, this count isn't necessarily true. So I believe 90 is going to work. Not that I've done any tests or anything. Taking a push apart factor, and I think just going for 30 is great, because when you're kind of cloning, once these become particles and you're cloning mixed simulation objects on, it's quite handy to have a bit of space. And the reason I've called this spawn is that there will be an outer collider, but more on that when I do the actual thingy. So we can actually, we don't need to do that. We'll save on a couple of clicks. So let's build some stuff. We're going to want our matrix object and a data node. Connect up your object port, and it would be nice to be able to not have to always be banging numbers in when you want to change something. So with a maths node, just take the count, which should be, you know, it should be true. I'm not going to grab a result node right now, but obviously this is something you have to double check if you're doing this, depending on, you know, what you're trying to do and what numbers you're on. So we also want an iteration node, and this will drive the iteration end, and then we'll grab another data node and we're going to drive its index, and always have to debug things a bit. So open up our position and global matrix, and we'll take a time node and a logic is null. And a pstorm node. Connect your emitter position and connect your global matrix to your emitter alignment. And yeah, in here where you've got birth count, birth number and particle birth, when you're working like this, your data set is this is kind of like hacking the node, really, iterating the positions and stuff. So if you're using the birth number, the data set isn't that useful if you're doing stuff like this. So changing that to short, changing the life to 300 and dropping everything including the speed to 0. And then now then, we should in theory get 90 particles. But do we get 90 particles? Look at that, it's a miracle. Let's drag our it might be an idea to rename this to UID Maxon. Might make life a bit easier. And I delete the count port. And so we need a custom data channel with a scale integer called UID Axon, and then just add that data channel. And this is probably a good time to mention before I forget, and then I can just shut that file, that some people might want to set this up on multiple emitters. Look at that, a bit lazy there. And I think the emitters have probably got exactly the same values, but they are working. I've already checked the data in the console. And yeah, these are they're both in count mode and producing reliable data that we can sort of do processing operations with. So, oh, what happened there? Hopefully nothing. So we've got our matrix with 90 and we've got the right number of particles. Now just want to make sure this is properly, get that down there, and crikey, we are going to need a P group node, and we're going to want to get our data, which we can get from here. And because we've done this, we've now got some useful information. So we're going to need, very much like the last video, we're going to need a condition node and 3 groups of particles. That's handy. condition, we want that in link mode, and we want another input. So group 1, group 2, and group 3. Now then, we also want a math node, which we put in modulo 3. And connect that up to there, and that up to there. Particle group to your particle birth, and the output of the condition node to your particle group. This works. It's a miracle. There you go. Miracle. Which is why I'm probably calling this impossible multi-group spawns with max on UID. This isn't the first time I've used this node, but what's in the last video isn't irrelevant. Did I say about the particle colors? You do have to set your data. I don't think I've mentioned that. Just because we've got colored particles, the material system uses that with the screen color shader, but the particles don't actually have that data, and I'm pretty certain Pyro doesn't pick it up unless you set the data. So that went quite well. Okay, and here's my thumbnail file, which hopefully will just render. Which, considering this is just a technical demonstration, I'm not very good at doing technical thumbnails, so I try and do something a little bit visual that's based on something. But what this is a 3-shot iterated spawn on this matrix object, and obviously I've colored it using Pyro and this vertex thingy here. But what I've done, basically there's 3 groups. So group 2 is not getting bubbled, but groups 1 and 3 are. So you've got these 3 particles that were born at the same location that are all going to do exactly the same thing, but you can control them differently. And obviously I did this just to create a visual example, but I've been doing this working with Pyro and actually leaving them on the same trajectory and having multiple particle groups with different settings. And obviously you can do stuff with the custom channels with thinking particles. I've been kind of like dabbling with, increasingly, with redundant particles that are just scene controllers. So I don't know, has that been any use? Basically you couldn't do this with the method I outlined last time, and I don't know, I think this is quite versatile. Let's bang this up to 1,000. Actually, there you go. Anyway, so thanks for watching. That's probably been about 15 minutes. Hope it's been of some use. Thanks for watching, and hope to see you again soon. Okay, bye.